Hey guys, I'm keeping 10.1 very short. Logical statements, and maybe if you took geometry in high school, you've probably seen this converse, contrapositive, inverse, and the conditional statements. I'm just gonna go over this single page note with you. Homework for 10.1 is posted. I do plan on putting one question on final exam about converse, contrapositive, or inverse. So we'll go over this in about 15-20 minutes. And the quiz 6 that's due this weekend, this Sunday, it doesn't cover 10.1. So everything that you've done up with these Excel functions, present value, future value, payment function, that's the kind of stuff, the amortized loans and credit card, those are going to be on 10.6. You do have 2 attempts on it, but with rounding and things, if you feel like you want to try a third attempt, just let me know. I can add another attempt for you. And if your answer was just off by like a couple cents, I can take a look at that too. But quiz 6 will not have any 10.1 problems. But I'm going to go over this with you very quick with you in case well, even if you saw this in geometry class in high school, I know they teach this in geometry. Well, let's go over conditional statement. So conditional statements will have a form of if blah, 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 then blah, blah, blah. So something like, if it snows, then the school will be closed. Something like that. Or if I have a sinus infection, then I have a headache. Something like that. So you'll be able to see kind of the 2 parts to it. The part that comes after if, we call that premise, and then the part that comes after then, we're going to call them conclusion. So if, let's make up an example today. That's a good, okay. How about we say, if I get sick, then I need to rest. Okay, if I get sick, then I need to rest. Oh, by the way, it's a single sentence, right? But then this part, if I get sick, this is the premise. And then this part is called conclusion. So if you can write a sentence in that form, that's what we call conditional statements. And let me read this box with you. An if-then statement, which may be true or false, right? It may be true or false, right? It doesn't have to be true. We can still write it in that form. Connects a hypothesis to a conclusion. So I called it premise, but also called hypothesis to a conclusion. So the part that comes after then is going to be conclusion. Let me go ahead and maybe do some coloring. So the yellow part, the part that comes after if is the premise or hypothesis, and the part that comes after then is the conclusion. Okay, if the conditional statement and hypothesis are both true, then the conclusion must necessarily be true also. Given the conditional statement, if P then Q, we can form 4 associated logical statements. The first one, something called negation. I'll start with that one too. So negation will go like that. If I get sick, then I don't need to rest. You see what I just added to this sentence, right? Don't. Negation means, well, keep the premise the same, keep that same hypothesis, but just go ahead and negate the conclusion. So if I get sick, then I need to rest. If that was the original statement, then you say, if I get sick, then I don't need to rest. You see how it changed, right? I guess the truth value changed, but that's how you make a negation. And in short, they're using if P, then Q. If that's the conditional, then if P, then not Q is how you make the negation. Simply negate the conclusion. Just put not in the conclusion. Now converse, let me go over converse now. Converse, like how we're having a conversation, we switch our words and our, converse is when you switch the premise and the conclusion. So it will go like that. If I need to rest, then I get sick. Now, is that true or false? Not really, right? If I need to rest, maybe I'm just tired. If I need to rest, then I get sick isn't really saying the same thing as, or doesn't have the same truth value as the original conditional statement, but that's how you make it. You simply switch P and Q. You switch them. And we'll do another example down there with something else. Now, contrapositive, a contrapositive is not only that you switch this P and Q, guys, you switch P and Q, switch and negate both. Okay, so it will go like that. If I don't need to rest, then I am not sick. And that sounds like a truth statement, right? If I don't need to rest, then I'm not really sick. But that's how you make contrapositive. You switch your hypothesis and conclusion, you switch the order, and then you negate both of them. Notice that I'm putting not, don't, and not when I'm making contrapositive, but that's how you make contrapositive. Now, inverse is you don't switch, no switch, just negate both. Okay, something like this. If I don't get sick, well, I'll say if I'm not sick, I'll say that. If I am not sick, then I don't need to rest. If I'm not sick, then I don't need to rest. Is that true though? I mean, is that almost saying the same thing as the original conditional statement? Not really, right? If I'm not sick, I may still need to rest if I'm tired after working so many hours. But that's really how you make these 4 different statements. So converse, so the original, if the original is P implies Q, then the converse will be Q implies P. The contrapositive, the longest word, right? Contrapositive is going to be not Q implies not P. And I'm using this symbol not. This symbol, this means negation. Not. This means not. Okay? Let's keep going with just these summary inverse. How do you make inverse? You keep the same order, but you just negate both statements. So not P implies not Q. And negation is simply keep that same order, but you just negate the conclusion. So let's do another one with another statement, okay? What's a good conditional statement? I think one year I did, if it snows, then I go to work or something like that. Let's do that. So conditional statements say that is, the original statement is P goes to Q. P implies Q. I'll say, if it snows, then school is closed. So this is a conditional statement, and I try to make it a true statement. Isn't it true? If it snows a lot, let's say, yeah, if it snows a lot, if we have severe weather condition, then the school will be closed. So this part right here, if it snows, what do we call that part? This is the hypothesis, right? Or premise. And this part, then the school is closed. The part that comes after then, oh, I wanted to use a different color. Then school is closed. This part is called conclusion. So let's make these conditional statements. First, how do you make converse? Converse is simply you switch the P and Q, right? So let's switch the order. If the school is closed, then what? Then it snowed. Okay, so is that true though? Suppose, well, we're gonna say, I'm gonna go ahead and say this is true. I'll say true statement. Because if it snows, then school will be closed, right? Now, the second statement, the converse that we just created, is saying something different. If school is closed, then it must have snowed. Is that true? I mean, did it snow last night? Because school is closed today, right? No. We just have coronavirus everywhere. So, I want to come back and talk about it, but this is not a true statement. If conditional statement is true, the converse is not necessarily going to be true, but we'll see which ones are kind of pairs, okay? We'll write all these statements, and then we'll come back and talk about this very important thing, the logically equivalent piece, okay? We'll come back and talk about what I just highlighted up there. But you notice what I mean by that's not true. If school is closed and it snowed, that's not really true because, it didn't snow last night and the building is closed, right? Nova is not closed. We still are learning, but the building is closed. So that's not necessarily true. How about contrapositive? That's going to be not Q implies not P. So you're going to have to negate them both and switch the order. So it will go like that. If school is not closed, oopsies. Then it didn't snow. Because of all these negations, it's kind of hard to interpret this, but is that true or false? If school's not closed, then it didn't snow. In other words, if school is open, then it didn't really snow. That's true. Because if it snowed, I shouldn't really go back to the conditional to say that, but if school's open, then it didn't snow last night. Because you know what would have happened if snowed last night and the school would have been closed. So this is a true statement. Now, the very last one, the inverse. I'll just keep it as like brown color. Inverse is when you negate them both, but then you just keep the same order. So it goes, if it didn't snow, then school is open. Now, is this true or false? And I said open, but we should say not closed. If it didn't snow, then school is open. Is that true? It didn't snow last night, right? It didn't snow last night. But is the school open? No, it's still closed, right? Corona. So this is false statement, guys. And this was my attempt of showing you that two are paired up together. Now take a look. I'm going to go ahead and draw some stars next to these two. Conditional statement and contrapositive are going to be, and this is the word that we use. Conditional and contrapositive are logically equivalent, okay? So these two are going to be, if conditional is true, then contrapositive will be true, okay? The other ones, let me draw some blue stars next to it. Converse and inverse, they are logically equivalent. So I will also add that statement underneath here. Converse and inverse are logically equivalent. So if converse is true, inverse will be true. If converse is false, then inverse will be false because these are pairs, okay? And you may be able to make up a statement where all of them are true or all of them are false, but that's okay. You just got to remember that if conditional is true, then contrapositive must be true. If conditional is false, then contrapositive must be false. They are logically equivalent, okay? Negation, let's just write that quick negation sentence. P implies not Q. If it snows, and we're saying the opposite thing, then school is open or not closed. Is that true or false? If it snows, then school is not open. Not closed. The school is open. If it snows, the school's going to be closed. So this will be a false statement because if the negation is simply saying the opposite thing of conditional statement. But when we talk about logical equivalence, we just always pair up conditional and contrapositive and converse and inverse, okay? I think by just knowing this much, you should be able to complete 10.1 homework. I just want to keep it very short. Since with everything going on, I do want to go over project 2 with you in this this week at least 3 more steps, because I know you got started on 3 steps last week. I want to also go over 3 more steps this week. But that's it for 10.1. I'm keeping it very short, and I'll probably do the same thing for 10.2. Well, I'll keep the last 2 lessons of Math 154 pretty quick. You still should be able to work on your Math Lab homework. Remember, this one it's going to be a little bit wordy. Not really math, but logic stuff. So